Good day students, I am Somasundaram from Bharatdasanar Matriculation Higher Secondary School, Arakona. Today we are going to discuss about the solution chapter. In our previous sessions we have discussed about how to find out the concentration of the solutions, molarity, molality, normality as well as percentage solutions have been discussed in our previous videos. Today we are going to discuss about the making of solution. When you make a solution, what are the properties have been affected if you consider a solvent. Okay. First one, we are going to see a gas in liquid solution. When you dissolve a gas in liquid, what are the quantities we can expect? Yes, the pressure. The pressure of the gas may affect the solution. So here the phenomena has been best explained using a law. That law is called as Henry's law. What is Henry's law? This law states that at a constant temperature, when you have a solvent above that, the gas will be there. Okay. The gas, if the pressure of the gas is more, the dissolution will be more. So the dissolution and then the pressure will be in direct relationship. That is stated by Henry's law. Okay. See here, there is an illustration. Here we have a gaseous particles above the solid liquid one. Okay. Liquid solvent. When you have lower pressure, the dissolution is very less because the contact between the gaseous molecule and liquid molecule is very less. When you apply greater pressure, more pressure than the previous one, what happens? The contact between the gaseous phase as well as the liquid phase is increases. If the contact increases, the dissolution also increases. So that is what happening here. So the pressure of the gas is directly related with the dissolution. So then how can we express the dissolution, which can be expressed by the mole fraction of the solute. Mole fraction of the solute. Now see the pressure is equal to, and the pressure here we are denoting about the gas. Okay, the pressure which is directly related with the mole fraction. So X refers here for gaseous one. Okay, so the mole fraction for the gas which is dissolving in the liquid. Okay, so P is directly related with mole fraction. Now we can equate. Okay, when you want to equate this quantity, we have to introduce a constant. So that is P is equal to KH and into X. So the constant we are introducing here is KH. What is KH? The KH is called as Henry's law constant. This is a very important quantity, Henry's law constant. We will discuss what is Henry's law constant and we can give some definition for Henry's law constant also. P is equal to KH into X. See here, there is a graph is given. What is the graph is telling us? When the partial pressure of the gas increases, the mole fraction dissolved in the solution of the gas also increases. We are getting a straight line. Okay, here we are getting a straight line, right? So we can equate this P is equal to KH into X. We can equate this equation with the linear line equation. That means a straight line equation. What is that? Y is equal to mx plus c. Y is equal to mx plus c. If you compare these two equations, the y axis is actually pressure. So that is why we are using the pressure in the y axis. What about the x axis? X axis is mole fraction. Okay. And what about the c? C is actually 0 here. C is actually 0 here. What is c in a straight line? C is telling about the intercept at y axis. So, I said the C value is 0. Now, see here, the line starts at 0. That means intercept at y axis is 0. What about the slope? M is equal to slope. So, M, the slope is actually the kh value. So, students, using this graph we can identify the value of kh for each gases. Okay, it varies with the different gases and also different solvents. So, the kh is changing. Okay, the value is constant for a particular gas. Okay. See here, some of the values of kh has been given. What are they? First, helium at 293 Kelvin, the value is 144.97. Next, hydrogen at 293 Kelvin, the value is 69.17 kilobar. What about nitrogen at 293 Kelvin, 76.48. Whereas the nitrogen, when the temperature increases, the bar pressure also increases. That means it requires more pressure to dissolve at higher temperature, because for a gaseous solution, temperature affects the solubility. If you increase the temperature, the solubility is decreasing. So, we have to give more pressure to increase the solubility. That is what happening here. So, at elevated or at higher temperature, the kh value increases. Okay. So, next example, oxygen. At 293 Kelvin, the value is only 34.86, but when the temperature increases up to 303, that means only 10 degree is increased, the value is around 46.82. So, the pressure required to dissolve the same quantity of oxygen requires 46.82 kilobar pressure. Thank you, students. In this video, we have discussed how to find out the dissolution in gas in liquid. Okay. In this video, we have solved a equation, that is P is equal to kh into x. Okay. In our next session, we will discuss some of the problems related to Henry's law. Thank you very much.